Hello everyone, this is the third video and we'll be discussing about beginner semantic in this video. We'll be using Autogluon to make an application which is called as semantic segmentation, which is a computer vision task where the objective is to create a detailed pixel-wise segmentation of a map of an image. So the segment anything model, which is also called as SAM, is a foundational model pre-trained on a vast data set with 1 billion masks and 11 million images. So while SAM performs exceptionally well on generic scenes, it encounters challenges when applied to some specialized domains like, remote sensing, agriculture and manufacturing, and medical imagery. So fortunately, we have AutoML that comes to rescue by facilitating the fine-tuning SAM. And to begin with, we'll be preparing the data and let's just install the modules the way we do. And after the installation is done, we'll first load the file. The file is loaded in this. We are using the dot unzip to unzip the file, and then we're going to read the data set which has multiple files present in that, train.csv, val.csv, and test.csv. So we know that the image column will be image and label column is label in this data. So we'll be uh, giving this image and label column as label and images, and then what we're going to do here is look at the data, how it looks like. So this is the image and this is the label for the image. And now let's try to visualize the data. So here is the image of the leaf we're thinking. And once we plot the label, it looks like somewhat like this. And after the zero shot evaluation is done, uh, now let's see how well the pre-trained SAM can segment the image. And for that, we'll be using multimodal predictor and we'll save that in the predictor zero shot. And once we save it, we'll use the predict function to predict how well it predicts. So now what we can note here is that SAM without prompts output a rough leaf mask instead of, the disease mask which we saw earlier. So it lacks a little context. So um, you can conduct a shot evaluation on the test data as well. So that is what we have done here. And now what we'll be doing is we'll be fine tuning SAM. And here we are again using the same function, but now we are fine tuning it by giving it some parameters like time limit. And once that is done, we'll again predict, we'll again call the predictor evaluate function and see what is the prediction coming out to be. So fine tuning kind of improves the score, but since this is done for a demonstration purpose and I don't have that much GPU power, that is why it does not give a good score. But if you provide it for a longer time, since I just provided the model with shorter time, 180 seconds, so that is why I did not predict correctly. But yeah, it is not exactly showing the disease image, but yeah, it works a little better than the one Sam was acting. Again, so here we just load the data and we can use the data for later. So let's go on to the next classification problem. So what we'll be doing is, as the name suggests, we'll be doing document classification. So paper document is an organization in an organization are a crucial source of information, regardless of industry. Dealing with paper documents is a headache. So what we'll be doing is we'll be trying to classify different types of documents so that dealing with this problem is easier. So we'll get the document data set and we'll start by that. Okay, so we got the document dataset, we unzipped the file, and then we loaded using again the pd.read CSV using pandas. And now we have the train and test dataset with us. Now what we'll be doing is we'll try to visualize what kind of data we have. So that is where we are using display function. And now we'll train the model and we'll try to give some hyperparameter. So we're giving the best one. I set the limit to 120 seconds, and so it just completed like 50% of a single epoch, and now it's time to evaluate. So it is showing like 0.5, that is the 50%, which is a fair enough for a prediction. And now what we're trying to do is predict on a new document. So basically, this is where the testing begins, and we're gonna give this image to our model, and here it shows what kind of what is a percentage of different types basically. And from here you can extract the embeddings of this. So what usually happens when a document is readed is it is converted into embeddings, that is a kind of a vector table. So that is what we are doing here. Now let's go to PDF classification. So PDF comes short from portable document format, as we know, and now we'll be using to classify different PDFs. And for that, we'll first again get the data of PDF's document set exactly, and then we're trying to load the image and how the data looks like basically, and then we're gonna um, make sure that we have data at a single variable, that is train data and the test data. So then we'll create a PDF document classifier again by using multimodal predictor and the fit function. And I'm setting the same hyperparameters as we set for the document classification one. And it will give us a model, and it has an accuracy of 62%, 62.5%, which is pretty great. And now we'll predict a new PDF using that. And it is telling us that the model, the PDF file that we uploaded was a resume, and it is saying that the chances of it being resume is 66%, which is great. And so basically, you can leverage Autogluon to make some prediction models, and you can just provide it with some really great computational power, and it works like magic. So now in this next collab, what we're going to discuss is text-to-text semantic matching with AutoML again. So computing similarities between two sentences is a common task in natural language processing. So with several practical applications such as a web search, question answering, document deduplication, plagiarism comparison, and the one we did earlier, document classification and PDF classification. So this is the rudimentary step, text-to-text semantic matching for the same. And we begin with preparing our data, and we have loaded the data into the SNLI train and test variables, and this is how our data look like. It has columns like premise, hypothesis, and label. So what we're trying to do is predict label, which label means if these two sentences are similar, it will give you a 1, and if they are not similar, it will give you a 0. So we'll train our model, and we'll be using multimodal predictor again for that, and give it queries like premise and hypothesis, and also label equal to label. Again, we're having the data set where the label of our data set is label only, and we'll predict using the fit function, and we'll set the time limit as 180 seconds. From that, we'll evaluate the test data set. So it is giving us a score of 89%, which is pretty great. And now what we can do is predict on a new sentence pair. The previous prediction test was done on the test data. This is for a new prediction pair, and it predicted entities as 1. So predict matching probabilities. So we can also compute the matching probabilities of sentence pairs. So that is what we're doing. What is the matching probability of two different sentences, basically? So it shows that if they are similar, that is, it shows that there is a chance of 79% that two sentences given in the pred data are similar. So if it is usually if it is a probability which is usually more than 50%, it turns to go in that way. So in this case, it will predict that those sentences are similar with an accuracy of 89%. And now we'll extract the embeddings, and that's all for this collab. Now we'll be discussing about image to text semantics matching, and here like vision and language are two important aspects of human intelligence, as we know. So to understand the real world problem, these two are the most important, vision and language. So what we're going to do is text semantic matching, and we'll be measuring the visual semantic similarities between images and text. So to begin with, we'll load the data set and then process the data set and load the CSV files to the appropriate variables, and then we'll try to visualize what kind of data it is, and display some of the images, what data we are dealing with basically. And then we'll use multimodal predictor again for the same purpose, and save it in the predictor variable. And we'll directly evaluate on test data set, which will be a zero shot. So you may be interested in getting the pre-trained models performance on your data. So for that, what we'll be doing is we'll be using predictor.evaluate function. And then once we are done with that, we'll fine tune our predictor. So what we are doing here is we're using the fit function to fine tune it. And so basically, when you're done with using the multimodal predictor, the data is pretty much done and computed and complete for itself. But if you want some fine tuning and you want your data, you want your model to be, um, really accurate. So that is why you do fit. And here will predict whether image and text match or not. So that's it for this collab. Now let's go to zero shot image one. So our task is the task of image text semantic matching refers to measuring visual semantic similarity between an image and a sentence. So what that is what we're gonna do here. We're gonna prepare the demo data for this, and once we're done with preparing the data, we're gonna load the data, and these are the URL from where we're loading the data, and this corresponds to these texts, and based on this text, we'll be training our data, and we'll be using multimodal predictor again for the same, and extract the embeddings, and we'll be extracting the images and its embeddings, and we'll try to uh, basically match the similarities. Once we are extracted the image, we'll have embeddings, and from the text we have embeddings, and if those embeddings um, show a great result for cosine similarity, then they are similar. So that is what we're trying to do. And text embeddings are extracted by predictor.extract embeddings. And now we are gonna use hit semantic search, where we are gonna make our query embedding, which will be equal to text embeddings, and response embeddings will be equal to image embeddings. Then we'll try to find the text retrieval with image query. So if we give it a text, what image it will show us. So given one text database and an image query, we can search text that match the image. So that is what we're trying to do here. And again, we'll use the same semantic search function for that. And finally, we predict whether image text pair match or not. So here what we're trying to do is we need to initialize the predictor with the additional arguments, query and response, which represents name of image text and text image, right? So once we are done with that, we'll hit the predict function, and it will start generating the model, and then we'll see what is the probability. So it is also easy to predict the matching probabilities. You can make predictions by applying customized thresholds to the probability. So that's all for this video. I hope you learned something out of this. And if you liked the video, please hit the like button and subscribe to my channel. Thank you.